Bayes classifier. Up till now we have seen KNN and linear regression. In linear regression we just fitted a line between group of observations. In the KNN the concept was Euclidean distance. Now in this Bayes classifier it is simple. The concept is simply the probabilistic approach. We use Bayes formula, which you can see here is probability of something given this condition is equal to likelihood into prior probability upon total probability. So the standard Bayes classifier in this implementation assumes independence of predictor variables and Gaussian distribution of metric predictors. What I mean by this, I'll come in the next slide. So this is a simple formula. Now let's look at this table. What Bayes classifier does is it accounts on the frequency of total observations which it had already seen, and based on that frequencies or likelihood table, likelihood table is this thing, on that likelihood table it estimates a probability given a certain condition. Like for example, I have taken here an example of spam or ham. I have 4 words: Viagra, money, groceries and unsubscribe, which are in the data set which I have trained the model with. So let's explore this likelihood table, what it signifies. Spam and ham, there are total 20 spams and 80 hams, so in total there are 100 messages. Out of in 20 spams I accounted the word Viagra, yes, 4 times, and in the rest of the left, that is 16, I don't account Viagra. Same is with money, groceries and unsubscribe. And in ham, out of the 80 occurrences, I encountered the term Viagra only once. Rest I didn't had the word Viagra in ham. Similarly for groceries, like out of the 80 observations, I had 71 groceries terms in this ham message, and sorry, I didn't have 71 messages, I had only 8. In unsubscribe I had 23, and rest of the messages I don't have. So like this is the table which will be we will train the model with, and based on this table I'll account the word, so account the result. So for example, like if I have to classify, what does this expression signify? See, probability that given these set of words, what is the probability that a message is spam? This can be calculated using Bayes approach. We already have the probability of spam. So this is the probability of spam, like 20 by 100, it's 0.5. And given the probability of spam, what's the probability that this spam message will contain these set of words? So this thing can be calculated using these likelihood frequencies simply, and this is now calculated. Now divide by the total probability, that is probability given a message is spam, what's the probability that the spam contains these words, plus given a message is ham, what's the probability that this contains these words. So this probability will be the total probability. So now let's move next. So what I have done, I have given 2 code references, one for dataset households 84, which actually assumes the independence among the variables, and second is the iris dataset which we have already seen in the KNN algorithm. What this households 84 means is, like, this is the dataset which consists of 16 persons who will be voting, and based on those votes there will be classification into 2 categories, namely Democratic and Republic. You can clearly see the household 84 dataset by just viewing in the RStudio. Then I have taken iris dataset, in which there is actually no independence among variables. This result will be quite amazing. After I have gone through this code, I will be covering the result in the next slide, so you'll actually be amazed to see the result. Why I am emphasizing on the fact that the naive Bayes classifier should assume the independence of the predictor variables. Here the after running this code, like what I have done in this code is I have called the library e1071, which actually includes the naive Bayes function. So I have to call this. Then I have called the data set households 84. Then I have fitted my model with the data set households 84 1:400. I have taken this as a training data set, 400 rows of this data set, and I have assigned the predictor variable as class, which is actually the democratic or republic, and these are the dependent variables. Dot operator signifies all the variables in this data set will contribute for the classification. So I have my model, then I am predicting the model using predict command simply. Then I am storing this predict model thing in a pred variable. Then I am comparing my accuracy of the model using table pred and households 84. So this is simple. What is the result is like this thing. I have predicted variable demo and republic, and I have these are original democratic and republic. Out of 35, I think, yeah, I have taken 35 observations for testing. So out of these 35, I have got total 17 democratic correctly, and republic 16 correctly. So there are in total 2 errors, which are actually false positive and false negatives. So this is like good accuracy, but this accuracy is based on this independence of the predictor variable. So be cautious of that when you choose naive Bayes classifier, that the variables are clearly independent. Why in this dataset the variables are independent? You can relate it to, like, if you are going to vote, if you're going for voting someone, then your vote doesn't depend on some other person vote ideally. So this house votes 84 is assuming that all the 16 persons are assuming their vote to be independent of each other. That's why this is a good data set for naive Bayes. Now in this iris data set, what I have done, I have called the iris data set. I have used this function just to like randomize the data set. Like in the iris data set, as you can clearly see in here, we have all the rows of setosa like in one module, then versicolor, and then other classification. So this this lining of the data set will not be a good training model, because it will train according to setosa and versicolor, but for the next classification it will give error. So better is like you randomize your data set properly. So that's why I have written this randomization function. What I have done is I have called here the function split df iris and 808. 808 is a, like, I have provided this as a seed so that I can reproduce the results. Iris is the data set I have provided. So if is dot null seed, if seed is not equal to null, then just set the seed equal to seed, which I have provided 808. So what I have done here, index is 1 is to total rows of the data frame. So there are, I think, total 500 or something observations. So I have just created a numeric vector of total number of rows. Then what I have done, I have used the sample function, which is just like a random function. It what it does, it takes a vector, and then it samples total length of this from this vector. So I have taken a length of 4 by 5th of total number of rows. So like it will consist of almost like 4/5 of the indexes. So that will go in the train index, and train set will be like, I have assigned the same thing, data frame equal to train index. So all the training data will go into train set, and test set will contain all the indexes which are not in train index. So this data frame will give all the testing observations to test set. Then I have returned these two vectors, these two data frames in form of list. so that I can return two outputs at the same time. And then what I have done, I have actually converted, because this is a list, it will return a list. I have converted these two splits 1 and splits 2 into the data frames, and then assigned them to iris train and iris test. Then I have used the naive Bayes classifier. This is a simple syntax. You can clearly read from this block how to approach for the naive Bayes prediction. Then for the accuracy, I have used this table. So the result will be actually like this. These are the original variables, these are the predicted. So like Setosa is clearly Setosa 7 out of 7. There are total 7 correct outputs, but in versicolor there is 0. Actually Setosa and versicolor are matching, and Setosa and Virginica are matching. So actually there are no versicolors and there are no Virginica actually matching correctly. So there are actually total 23 errors out of 30 observations. So this is a big defaulter for this thing. So why is this actually happening? This is actually happened because of the relationships between sepal and sepal width, petal length and petal width. You can see from this graph, like this ellipse, you can see here, this is showing the relationship between these two features, any two features. So you can clearly see that the species, this is the classification section, this section is actually dependent on each and every feature, because this ellipse is actually stretched. The more the ellipse is stretched, the more the stronger the relationship is with feature of that classifier. So a species is actually dependent on these things, and in turn also the sepal and sepal width, petal length and petal width, these are also dependent on each other. So you can't actually use naive Bayes, because naive Bayes tells naive Bayes actually uses the concept of independence among the feature variables. So this will actually give error because of the dependence thing. Okay, so in this video I told you about the naive Bayes classifier. In the next video I am gonna tell you about the logistic regression. Thank you.